because you cannot really control the location on the heap of objects. But you can see when they are linear, the cost is tremendously less. It's 20 milliseconds now. It's nearly half the time. But then when we go to structs, it's 10 milliseconds compared to the initial 35 milliseconds. So you can see the dramatic impact on the garbage collection performance there with just that single simple change. And then the last case, just to illustrate that point, when we get rid of the reference to strings in the character class of struct entirely, the cost drops down to almost nothing because the garbage collector knows it doesn't have to scan that array. So aside from laying out your data appropriately, the other thing that you can do is minimize allocations to avoid the garbage collector kicking in the first place. So this is basically something that has to be done on a case-by-case basis. So if you use temporary buffers, try to reuse them, or in general, reuse allocations. Use pools to keep objects of certain types around, stuff like that. Reuse allocations in order to lower the pressure on the memory subsystem. Then, as just mentioned, use structs instead of classes when you can. They're inlined, they are much faster. And finally, don't use the old on-GUI system and all that stuff. Like, one cost that isn't so obvious is that it's really bad with the memory. Like, it just allocates all over the place. It's really not a good system. Use the new UI system. It's really optimized with a view towards memory and overall performance. So here's a very simple demonstration of how important it is to reuse allocations. I hope you can read it. Like, it's a very simple artificial case. Like in the first case, on the upper left, there's a simple method that we call on each update, and we just allocate a new buffer every single time. And in the lower left corner, what we do is we simply reuse that allocation every single time. It's a very simple change, but you can see that the effect on performance is dramatic. Like, if you look on the right, you can see it being shown in the on the lower left in the snapshot. And also, like in the graph, you can see that roughly every 10 frames, the garbage collector kicks in and has to do work. So you get very, very uneven performance, just because the garbage collector comes in every now and then and completely destroys things. Whereas in the case where it doesn't allocate, things run smoothly. So, as mentioned, pooling, that's the prevalent technique for reusing allocations. So one goal is to get the pressure that you put on the memory system down. The other is instantiating and destroying objects actually has an overhead itself as well. So reusing objects is a good means to get rid of that overhead. Problems are when the pool is empty, you still have to instantiate it. You still have to return some objects. So when you start the gameplay and your pool is empty, things still stutter, and it takes a while for the pool to warm up. So it may be necessary to warm up the pool manually before you start using it. Also, one thing to keep in mind is all the stuff you put in the pool adds to your managed heap size, even though it is data that you're not actively using. So that stuff, even though it's not actively being used in your gameplay, still has to be traced by the garbage collector. Most optimal thing is when you get to the point where you don't have any kind of dynamic allocations during normal gameplay, and the garbage collector never kicks in during normal gameplay, that point becomes moot. So in terms of how, one important thing is like avoid things like you don't want the scenario where the pool itself creates garbage. So use data structures that don't themselves dynamically allocate. Like a dictionary usually does, not a good choice. Use a fixed size list pre-allocated with a certain size and chuck things in there. As mentioned, warm up things. Like if you have a gun that fires 100 bullets at most, put 100 bullets in there if you can, and just use them and you know you're safe. Also, like, what do you do with the objects while they're in the pool? The most obvious thing is to just disable them and then enable them when they come back out of the pool. But for very complex game object hierarchies, that may actually not be the most performant way. So if you can, just enable and disable specific components like mesh renderers and colliders. Or if you can, just move things out of the way while they're in the pool and move them back when you need them. Like, choose whatever works. Like, the good news is, if you go with the activation route, in 5.0, we made both object instantiate and the object destroy and the activation times, like we made that a lot more performant. Like I ran some tests before the talk and in general found that Unity 5 is about twice as fast, like with all these calls compared to Unity 4. So in most cases, you're fine just going with the activation for your pool. So coming to the end of this, let's just look at some very, very generic and general performance-related tips and tricks. There's the oft-repeated advice, don't use game object find. Like, definitely don't use it during normal gameplay. Like, this function is extremely slow. It just goes through all the objects and looks for the one with the right name. Also, it's very brittle, actually. Like, you change a name over here and something over there breaks. The best way to do it is to just use direct linking. So you have a property of a certain type, like game object or a component type, and you just assign the right object to it. This also has the benefit that if you build a player, it will see that reference and make sure that all the data that is being used by that reference object also goes into the player. And also, if that other object goes away, the reference clearly breaks. If you do go for the lookup methods, especially like also get component, don't do get component in a tight loop. If possible, look up the object once, store it somewhere, retain the reference. Also, one thing that people don't often keep in mind is that a transition between the low-level engine and your script code has a certain overhead. So let's say, for example, that you have 1,000 agents that need to be updated, and each has a certain state. So the most obvious solution in Unity is to just have a mono behavior that represents an agent, put the state in there, and have an update method on there. And then have 1,000 game objects and put that mono behavior on every single one of them. The downside is that now what the engine does is it calls update from native into script 1,000 times. Also, it adds 1,000 game objects and their components, which is quite a considerable overhead. So this is going to be pretty slow. A better solution is to have a single mono behavior that has the state for all 1,000 agents in there, has a single update method that in a tight loop updates all the agents. So the native code calls update once, it runs the update in a tight loop and on a tightly packed array of data, and then goes back to the engine. That's like, you won't believe how much of a speed up that is actually. Also, that ties into another point. Like, it seems like game objects and components in Unity are the go-to method for making anything happen. But really, like, if you don't need the facilities provided by mono behavior, don't use it. Like, it's a pretty heavyweight object. Just go with normal C# classes and don't use any of the, don't derive from any of the Unity engine objects. Also, if you don't need a game object, don't use one. Like, these are really quite expensive. Also, transform hierarchies are expensive. Like, if you nest objects like crazy, that has quite a cost. Like, if parent changes, that may mean that a lot of child objects need to be updated, and it also means that if a child changes, it depends on a lot of parent transforms. Like, usually, if people, like, when they create their scenes, they create all kinds of folders to organize things neatly, which is good. But when you deploy the game, this is really something that you don't want. All these things that serve no purpose other than making things nice for the designer, get rid of them. Flat hierarchies and flat lists are the best. They're the most performant thing. Also, like if you have complex rigs, make sure you use optimized transform hierarchy to get rid of all the extra transforms that you don't need to script or animate. Finally, let's take a quick look forward in terms of what's coming with performance. One thing we've started with Unity 5 is we want to empty out the main thread more and more. Ultimately, our vision is that the main thread is available to scripting exclusively and to high-level control flow, and all the rest happens on background threads. Unity 5 has made big strides there, but we still have a lot of work ahead of us. Also, streaming, we want more and more of the asset subsystems. They need to work in parallel completely. We've made strides there, like with the texture loading, for example, but there's still work ahead of us. Native performance, IL2CPP is a big thing. We want native or native-like performance across all platforms. And there's a lot of additional stuff that we can do there with garbage collection, with people being able to use our native high-performance SIMD math library from script code, stuff like that. We want to optimize transform hierarchy a lot, because right now it's one of the most expensive parts in Unity. And if you look at it, it's really the central communication hub in the entire engine. And it's very complex, and refactoring is quite a challenge, but we have some ideas there and want to do a lot more there. And finally, better tools for you in order to find your bottlenecks. Like we started, we started in Unity 5, but there's more on the way. Like, for example, a project that is currently being worked on and will ship pretty soon is what we internally refer to as Project Pogo Stick, which is a replacement for deep profiling, where you can hook specifically into methods, script methods that you are interested in. And without any recompilation, we will be able to instrument that method and profile the cost of that method for you. It's a very neat tool, and we'll be there soon. Wrapping this up, let's just go over some of the points that came up real quick. Load asynchronously to reduce wait times, don't make the player wait. Use our async APIs to do the loading. Then beware of memory usage patterns, like how you lay out your data, use structs instead of classes, all that kind of stuff in order to reduce the cost that the garbage collector incurs when it runs. And then try to not make the garbage collector run in the first place. Like in most cases in your game, during normal gameplay, you want 0 allocations. Cache the results of repeated work. Like if you look things up, whatever you do, if you compute costly stuff, don't do it over and over again. And finally, the by far most important thing, like in terms of performance, people can talk all day long about what you should and should not do. What ultimately matters is really what your game does and where your bottlenecks are. In most cases, it doesn't even make sense to worry about performance until you find out what's actually running slow. So use the profiler in Unity, as well as use any profiling tools available on the platforms. Like there's really good stuff out there. Use it to find out where your bottlenecks are and find solutions for those, rather than stick into, okay, you should do this and you shouldn't do that. Finally, just for things that want some more in-depth, people that want some more in-depth stuff, these are some pointers to some really, really good talks. Like the two are from previous Unites, especially the second one goes into detail quite a lot on third-party tools on mobile platforms to optimize performance there. And the last talk is a very, very good it's a bit of like a post-mortem, like an actual case where someone said, okay, this is where we started at, this was our performance at the start, and this is all the stuff we did in order to make things run fast. It's mostly graphics stuff that they do, but it's a really, really good talk that I can highly recommend. And yes, so that's pretty much it. I hope it was useful in some form. I'll stick around. Like if you have questions, just come up and ask. So yeah, that's it. Thanks for being here. And yeah, enjoy your night.